Okay, so let's start with today's class. Am I audible clearly?
Yes, sir.
Yes, sir.
Thank you. Now, today, okay, so far we have talked with mainly computer vision, a part of the deep learning methodologies. Okay, now computer vision is necessary to work with images. Okay, especially in biomedical signal processing, we'll have to work with different images. So you already have some idea how to form CNN architecture, what are different components of the CNN architecture. Okay, and also different components, also how to use augmentation, deep learning, transfer learning, and these necessary concepts to actually form a proper CNN architecture. Okay, so based on this, you will have your open-ended lab 1. I'll provide it soon. So this is up to your CNN. Okay, we have talked with that one enough. Now we'll just talk about biomedical signal modalities. Okay, how different biomedical signals are formed and discuss on those things. So we'll start with something very common, that is our X-ray. Okay. So many of you have already done X-ray once or twice in your life, so you are already familiar with this idea. So we'll talk about X-ray, try to understand how these X-ray images are formed. Okay, how to work with these images, what are their problems and different issues. Let's try to understand. Achha. Now, X-ray, this actually belongs to our electromagnetic spectrum. Electromagnetic spectrum. Spectrum. So in the electromagnetic spectrum, you have different types like microwave, infrared, then visible light. Okay. Then you have UV, then you have X-ray, then you have gamma ray. So different lights. This is what we can see, the visible light, and this is what we are trying to do, X-ray. So how these different types are different, how these are different based on what? This electromagnetic
Based on
radiation.
frequency,
Yeah, frequency or wavelength.
wavelength.
So frequency or wavelength, what actually differentiate this one type from another. Okay, so as we go rightwards, the frequency actually increases or the wavelength decreases. So when you have this X-ray, when you are in this X-ray, these are actually very short wavelength. Okay, very short wavelengths. So X-ray images are actually very short wavelengths in the nanometer region. Okay, in the nanometer. So nanometer is like, I think it is from 0.124 to 0.00124 nanometer. In this range, or normally the X-ray X-ray radiation is formed. Achha. Now the photon energy, the X-ray photon. Okay, the photon energy is usually from 10 kilo electron volt to 100 kilo electron volt. We'll talk about this one later. Okay, so this is your X-ray. You have the radiation, electromagnetic radiation in the nanometer range. Okay, very short, very short. Achha. Now let's try to understand where it actually started. I believe you already know the scientist was Röntgen, Wilhelm Röntgen. Okay. He was experimenting with gas discharge tube. Okay, he was experimenting with those things, and that was in 1895. Okay, and accidentally, he actually invented this X-ray. It was not intentional. So when he was working with this kind of gas discharge tube, see, it's like you have this accelerated electrons inside like a box, okay, a gas discharge tube. So he had this accelerated electrons in the anode, it's like this. Now he actually covered this one, okay, covered this whole things with, he actually covered this whole this gas tube. But when he was doing this experiment, there was outside, there was something that started to glow. But since this gas discharge tube was covered, no light can actually pass. That is the visible light. We are talking about 1895 at that time. no light should be able to pass through it because it was covered. But still, there is one side outside this gas discharge tube, one particular material was there in the lab, and that started to glow. Okay, so that actually made him curious. It was glowing. So what this is, so how this actually can grow, because everything is actually sealed up now. So that is actually at that time they didn't have any idea. He didn't have any idea what type of radiation was that. Okay, it was unknown at the start. At that time, what kind of radiation? These things actually came after 1900. Okay, after Einstein actually talked about photon and other things. So these things came later. So they didn't know what type of radiation it was. That's why actually they gave the name X-ray. Okay, the term X actually comes from there. At that time, they didn't know what kind of ray it was, what kind of radiation it was. That's why they termed it as X-ray at that time. And we still use this same terminology. And for this invention, he also got a Nobel Prize. Okay, now, any question?
No, sir.
So why it actually glows and what was glowing? The material there was, it was barium cyanide type. Okay, platinum cyanide type. Platinum cyanide. So why it starts glow? Because you see this particular material reacts with X-ray. Why it reacts? As you can understand, this is a very high frequency. That means high energy. High frequency radiation. That means high energy radiation. In normal light, it will have no reaction. But when you have this kind of high frequency light, it will have some reaction with this material. And that material, when it have this reaction, some photon actually emits. So it actually makes visible. And that's why you have that's why you have this material actually glowing. Now, so here what he was actually doing inside, what he was doing inside, he was actually working with accelerated electrons, not just electron, accelerated electrons. Okay. So the electrons were traveling. He was creating these accelerated electrons here, and this was traveling through a vacuum. This gas pipe, the gas tube was actually a vacuum, was traveling through vacuum. And here you have the anode. So these accelerated electrons traveling through the vacuum was hitting this anode. Okay. So when you have hitting this anode, it was also hitting this glass wall, anode plus this glass wall, which was covered at that time. And outside, the reaction that means this glowing, he was actually observing this one outside. Okay. So here is the catch. You see, when normal light cannot pass through this glass wall because it was covered, some radiation was able to move from here to there. Okay. So this idea that something that can pass through object, something that can pass through object, okay, that our visible light cannot. This idea make very much attention. It actually created a lot of attention that there is some type of radiation that can pass through object that our visible light cannot. Okay, so and we can actually use this concept for our need. Okay, so that actually created a lot of attention there, and subsequently different application actually rose, and till now today still you see X-ray is one of the most frequently used imaging modality that you use. Okay, more than 100 million per year worldwide. More than 100 millions of X-rays are actually conducted for biomedical imaging tasks. So X-ray is one of the most simplest, cheapest, and easier way to actually this kind of biomedical imaging. Okay. Any question? And this process that actually Röntgen used to actually produce the X-ray, we actually use the similar process, exactly similar. Some a little bit different in the type of the material, but the rest of the things is almost the same. Okay. Acha. Now, acha. Now you see this. Now, this idea that something can actually pass through an object, so it also created the idea, can it pass through the human body? Okay, or a biological medium, can it pass through human body? So they actually found that yes, it can also pass through human body. So when it can pass through human body, it has some potential. So you see, it's like, if you look at it, it's like shadow. Okay, you see, when you have this visible light, so let's say this is your visible light. When if you are standing here, okay, if you're standing here, let's say a human being is standing here, it will create a shadow. If you have put something here, so this light will create a shadow here. Okay, so other portion you will be able to see, and this portion it will create a shadow. But when you use an X-ray, you see what happens is that X-ray can pass through some of the materials and cannot pass through some materials. So the piercing ability is different. The piercing ability of the X-ray is different from different one. How? You see, it can pass through some things like our tissues or muscles. Tissues or muscles. Okay. And it cannot pass through, this X-ray cannot pass through bones. So what is the difference between bone and tissue? বলতে পারবা? ডিফারেন্সটা কি?
স্যার একটা সফট একটা হার্ড টিস্যু এরকম।
টিস্যুতে স্যার পানি থাকে।
So bones are actually dense. Bones are more dense. It is made of calcium. Okay. Calcium কত? 25. So higher atomic number. So these are more dense. And these are mostly made of hydrogen, oxygen, carbon. These are less dense. Okay. So X-ray can pass through these less dense materials, okay, a small atomic number, but it cannot pass through high dense material. So when you have this kind of thing, so it will be able to pass through some of the portion of the body. It will not be able to pass through other portions. So it can pass through our muscle. Okay, it can pass through. So it is like transparent to a muscle, but it will not be able to pass through our bones. So in here, when you form the shadow, you will get the shadow of the bones. Shadow পাওয়া যাবে না?
ইয়েস স্যার।
আচ্ছা তোমাকে so if you look at here, you see what you are doing here, you are just doing the same thing. You are just putting an image, that is putting the light, so X-ray radiation through your, let's say, hand, and you see this is the your muscle. Okay, and muscles and veins and other things, and your image, so your radiation is passing through these muscles very clearly. Okay, that's why it is not actually properly visible, but it cannot pass through these bones. That's why you have this shadow of the bones on the outside. You get my point? So this way you actually form this X-ray. Similarly, for your this is your chest X-ray, you can see the shapes of your bones exactly when you perform this kind of chest X-ray. So that's actually the basic idea. Okay, how this X-ray actually imaging works. Screen. Any question? Acha. So this X-ray images, so X-ray imaging technique, this has a major potential. Okay, major potential in biomedical imaging. It can actually perform a lot of different tasks. So it is, just like I said, most widely used. And there are some variations of it, and we'll discuss gradually of different X-ray modalities. We can actually do it for soft tissue. We can do it for hard tissue. So there are different variations. Also, very popular CT scan. This is a variation of the X-ray imaging. CT means computed tomography, right? Topography, no? Tomography. Computed tomography. So this is a more efficient way of actually performing X-ray images. Okay, we'll talk about computed tomography later. Okay, so let's try to understand our X-ray. Okay. Now, The materials actually can be divided into two types. One is called radio packed, and another one is called radio lucent. So radio pack means an object that is impenetrable to X-ray. And radiolucent means an object that is transparent, translucent. Object that is transparent to X-ray. So object that is impenetrable to X-ray, that means X-ray cannot penetrate the object or radio pack. It's like our bones. Okay. So our bones, X-ray cannot penetrate our bones because it is made up of dense material. So when you are actually passing the X-ray radiation through our bones, it will cast a darker shadow. Shadow means that's the visibility in the outside. So dark shadow means you will get low radiation exposure on the film. And this one will have high exposure. Okay. I'm going to draw you the arc, how we do these things. You see, this is your filament. Okay. And okay. So the of the electrons will hit this one. So this is your filament, this is your anode. Okay. This will try to on this target. Everything is called, this is called a X-ray tube. Everything happens inside the X-ray tube. So from this filament, the electrons are released. Okay. And they are actually accelerated inside this X-ray tube. So you have this, you see in the left side, the electrons are released, electrons goes this way, here's the target. Okay, and you see it is like 45-degree angle. There is a reason why it is 45 degree. বলতে পারবে কেন 45 degree? When it is in a 45-degree angle, it will actually absorb. The rays will be less absorbed by this anode. Okay, it will be more reflected. So this, after this reflection, it comes through, this is your patient. Okay, this is your patient. He is sitting on this, let's say this table. Okay, and below this table, okay, below this table, there is a film there. Okay. So you have the X-ray first created in the filament. The electrons are created in the filament. They are accelerated through this X-ray tube in the anode. When these accelerated electrons hit the anode in this region, when they hit the anode, high frequency photons are generated. These photons, actually, part of this photon, not all of them. Okay, some of them are actually X-ray. Okay, the radiation in the frequency of X-ray. Those X-rays are actually going through the patient's body, a particular portion. It can be your hand, it can be your leg, or your whole body, whatever you choose. And it will flow through these ones. And so you see when you are doing like a chest X-ray, the bones that you have here, it will create a reflection of the bones here. Okay, in the film, this is photosensitive film. Photosensitive. Just like a normal image is formed, same way photosensitive film. So the X-ray image, so the X-ray radiation will pass through the body. Some of the materials like translucent, it will be able to pass. So you will not have anything here. Very small, like small exposure, very small. But through the bones, it will not be able to pass. So from the back side, from here, you can see the structure of the bones, exact structure. So you can also find if there is a, like, if there is anything broken inside the bones, you can also see. This is how a X-ray setup Okay, this is like the X-ray setup, and same way it is actually performed. Okay, still today, just like previously, it's also performed the same way today as well. Any question? Answer, no question. Now, to understand the how this
স্যার
equation,
ফিলামেন্টটা কিসের তৈরি, মানে যে ইলেকট্রন যেটা ইয়া করতেছে, ইমিট করতেছে, এটা
কোন ম্যাটেরিয়ালে তৈরি?
মানে এটার স্ট্রাকচারটা কেমন, মানে এইভাবে ইন্ডাক্টর টাইপই, মানে ইলেকট্রনটা কেমন ইমিট হচ্ছে, এইটা এটা একটু জানার ছিল।
এটা আমাকে দেখতে হবে ফিলামেন্ট দিয়ে
আচ্ছা
কিভাবে
আচ্ছা
ইলেকট্রন
আচ্ছা
ইয়ে করে।
আচ্ছা।
পড়ছিলাম অনেক আগে, ক্যাথোড রে টিউব মনে আছে, ইন্টারমিডিয়েটে পড়ছিলাম ক্যাথোড
হ্যাঁ
রে
হ্যাঁ
থেকে
হ্যাঁ
কিভাবে হচ্ছে ফিলামেন্ট ইয়ে করে। আমি ভুলে গেছি জিনিসগুলো, অনেক আগে পড়ছিলাম।
স্যার লাগবে না,
দেখতে হবে
দেখুন।
ওটা। ঠিক আছে। আচ্ছা, নাও if we come here, so the energy that we have actually, আচ্ছা এখানে আরেকটা জিনিস আছে, সেটার নাম হচ্ছে কলিমেটর। we'll talk about this one a little bit later. Collimator. আচ্ছা। So you see the energy that you are getting from here, from this energy that is released after hitting the anode, this is equals to QV. Q is the charge of the electron and V is the potential difference. The potential difference that you are using to actually release the electrons from here. Okay, so you see, this is fixed, this is constant. Electron charge, this is constant. So the larger the potential you have, the more energy you will have in the photons. Okay,
Yes, sir.
so this is also equals to HF, or that is equals to HC divided by lambda. That means, so the larger the energy that you get from this portion, this is the generation side and this is the output side. The larger the energy that you can get from here, and H is this your Planck constant, Planck's constant, and lambda is your wavelength. Okay. So larger the energy that you can actually obtain from here, the greater the frequency or the energy that you get outside. The higher energy means high frequency or a smaller wavelength. Okay, so the wavelength that you actually need for the X-ray, that actually depends directly on the voltage that you are using. Okay, directly related, directly proportional to the voltage you are using to create these accelerated electrons. Okay, so this lambda is related to the V, the voltage that you are using to create the electrons. Okay, so previously I told you here, for instance, 10 kilo electron volt to 100 kilo electron volt. So you need that types of energy, electron volt. So voltage multiplied by this electron. So that's why you have. So you are using 10 kilovolt. Okay, so that will be the, based on this one, you can actually calculate what is the lambda of this of the radiated light, radiated radiation, electromagnetic radiation. So that's the voltage that you are actually uh, uh, transformed into the radiation, electromagnetic radiation. But here is the catch. The catch is, the problem is, you see, ideally, we assume that 100 conversion efficiency. So it's like, you see the electrons are passing through this one. So you have the kinetic energy here, kinetic energy of the electrons. After it is hitting the anode, it is actually emitting this radiation. But not all the energy of the electron will be radiated as photons. Okay, high frequency photons. Not all the energy will be emitted at photons. Ideally, we are assuming, based on this equation, that whatever your electron energy was, the kinetic energy of the electron was before hitting the photon, will get exact same amount of energy on the output radiation. But it does not happen in the real world. In real world scenario, can you guess how much percentage will be actually will get outside?
30 to 40.
So
60-30. In X-ray, actually X-ray generation, the X-ray generation process is highly inefficient. Highly inefficient. You see, we are not talking about UV, we are talking about X-ray. That's like one of the lowest that we can actually produce here. So the energy conversion efficiency is around 1%. Okay, very small, very tiny. So what happens to the outside? What happens to the other portions? Where goes the other energy? বাকি এনার্জিটা কি হবে?
লস।
Loss. So the remaining energy, you see, most of them, the remaining energy, and a large portion, okay, it is actually generated as heat. Okay, that's the problem. A huge amount of heat is generated. This kind of device, when you have this extra setup, extra device, a large amount of energy is actually released as heat. Okay, so you have to have some cooling. Okay, cooling is extremely important, very important for the X-ray device, and it actually controls the lifetime of your X-ray device. If you don't have proper cooling, your X-ray device will not last very longer. So you have to take care of the cooling side. That's more important. Okay. So most of the energy is actually released at this. So you have to take care of how you are taking care of the cooling. So if let me show you some extra device. So can you see the screen?
ইয়েস স্যার।
So you see, this is, I think you are, if you have done X-ray, you have probably actually did something like this. Okay. Here you have your X-ray device. You sit on this one and you perform the X-ray like this way. For particular portion of the body, they actually we'll talk about X-ray exposure a little bit later. So it actually goes through the exact portion where you are actually trying to do the X-ray. Okay. And you can see here is your X-ray generator, here is your object, and in the below, you have the detector, the film on which you get the actually X-ray output. ওকে, সেটার উপরে তুমি আউটপুটটা দেখতে পাচ্ছ, যেটা তোমাকে দিয়ে দেয়, পরে পরবর্তীতে দিয়ে দেয়। Okay, and one particular, this one, you see, this is, I think, yeah, this is a computer tomography. This is a little bit different. Okay, it like circles around your body. This one circles around your body to have a 360-degree view of your body, X-ray imaging body. So that's a more advanced techniques called computer tomography. We'll talk about this one a little bit later. Not today, next day, next class. আচ্ছা, so আচ্ছা, so you know how this X-ray setup works. You know the generation process. Okay, you know these things that you have to take care about. Now, some of the other things, like you have the detector, some of the uh, ingredients of the X-ray setup. So detector is like photosensitive film. I believe you already know how a film is created. So it's like a photosensitive film that reacts to your X-ray image. The collimator, okay, I'll write it this one. Collimator performs this task. You see, when you have something like this, it makes the beams parallel. There you have the collimator, right? Here you have the collimator. If collimator is placed here, it tries to make the beams parallel, okay, like a lens. Lens মতো কাজ করে. Also, the anode that you have, the anode material, this also controls the efficiency, how much efficiently light is actually emitted. So normally we use tungsten for this one, and I think that's considered the best material. Okay, so tungsten is usually used as the anode material. Now, when you are this after heating this anode, that is in this 45-degree anode, and it is actually releasing the photons like this way. So you see the energy that is emitted, it is emitted in different range. Okay, so there are short lambda. Short lambda means short wavelength that will have high energy, and it will also have long lambda, like long wavelengths with low energy levels. You will have both. You will have short energy levels, radiation of in the short wavelength range. You will also have radiation in the long wavelength range. Achha, so which one is desirable? Which one do you want?
হায়ার ওয়ান স্যার।
Higher energy or higher length?
higher energy is a
Yes, high energy. Because high energy will be able to pass through our body more. Okay, so these short wavelengths or high energy, this is more desirable. Okay, why desirable? Because they will provide better discrimination. Okay, they will be better pass through our different parts of the body. It will provide better discrimination, so you will get better quality image. That's what we need, better images. Okay, and the quality of the image, we'll also talk about this one a little bit later. Now, low energy, the problem is it will provide low resolution. Okay, so shallow penetration. Shallow penetration means it will not be able to penetrate different portion of the body properly. So it's like if you're extreme, so this wavelength, if it only penetrates half of the body, then actually absorb throughout inside the body, then it will not be able to hit this. So when you have this body, if it only goes through past half of them, if it cannot pass through the whole body and reflects on this photosensitive field, then it is no use to you. Okay, so this low energy wavelengths, low energy emissions, do we need these things? আমাদের কোনো দরকার আছে?
no, sir.
So this low energy emissions needs to be eliminated. If we don't eliminate it, because you see, these are not adding any new information, they are unable to pass through different portions of the body. So it will only just obscure one thing. It will obscure, if some of them passes not properly, it will obscure the image, the noise, it will add noise in the image, so it will reduce the quality of the image that you are getting. Okay, that is one thing. Also, this will also provide tissue damage. Okay, because that emission is absorbed by your body. Okay, if it cannot pass through, it will be absorbed by your body, and when you are doing this, it will perform some tissue damage to your body. Okay, what is the wavelength of your X-ray? You will select again. Wavelength কত ছিল?
0.125
Nanometer, right?
Yes, sir, nanometer range.
Nanometer. So you see, this nanometer is like the DNA level. Okay, so the DNA molecules in the molecular level. So the X-ray photons that you have, they will react with the molecules of your body. So the change will be mutagenic. Mutagenic by change in the DNA. Okay, in the genetic level. So this is not very desired. So you want to eliminate these things. Now, how to eliminate those things? How to eliminate this long wavelengths? Filter. Okay, we have to use filter operation. Filtering using কিভাবে? Metal plates. Okay, metal plates like aluminium. Okay, so you see metal plates like aluminium of different thickness depending on what is the different thickness, what is the radiation wavelength. So you see, some of the metal plates like aluminium will be able to absorb these low energy photons. Okay, but high energy photons will pass through these aluminium plates. So you place some aluminium plates, small thickness aluminium plates, from your source, the radiation source, through your body. In this sense, you put some actually aluminium plates so that the radiation, actually the low energy radiation, is absorbed by the aluminium plates. Okay, so they will absorb and it will absorb. Okay, and it will reduce this effect, and it will be able to eliminate this low energy, and you will get only this high energy and better quality image. Okay, any question? Achha.
No, sir.
Now types. Achha. Now types. There are different types of X-ray. So there are soft X-ray, okay, and there are hard X-ray. So the soft X-ray are generated using 60 kilovolt, less than 60 kilovolt usually. And hard X-ray is usually used more than 100 kilovolt, electron volt. So energy of the so less than 60 kilo electron volt, that means this is actually soft X-ray, and more than 100, that's called hard X-ray. Achha. So what is the use of soft X-ray and what is the use of hard X-ray? Hard X-ray used for like hard tissues. Because hard tissues like bones. Okay. So then why do we need soft X-ray? So there are other applications of soft X-ray. You see, we don't only always want the structure of the bones, we also need some other, sometimes for the muscles, sometimes for the other soft tissues like
Ligament.
for instance mammography. You know mammography? For mammography you need soft x-ray. Okay, so for breast cancer detection, breast tumor. Okay, so when you don't have this, so you have these different types of x-ray. It depends on your application. If you are going for like bones structure, you want to do for this one, you have to go for hard x-ray. So based on that, when you create this x-ray, you fix your the potential, the energy difference, the potential difference with this range. It will produce the hard x-ray, then you can do it. And also, so this is something you can control based on the device, based on the type of application. You change it, you can change it that way. Achha. Any question? So these are very simple. I believe you all understand these things easily.
স্যার
Now-
হার্ড এক্সরে আর সফট এক্সরে কি একই ডিভাইসে করা হয়, জাস্ট ভোল্টেজ ডিফারেন্সটা চেঞ্জ করে?
No, actually ম্যামোগ্রাফির জন্য সাধারণত ডিভাইস সবকিছু চেঞ্জ করা হয়। কেন চেঞ্জ করা হয়? You see, when you are doing this variation, also there is this cooling method. You have to change the cooling method. So usually you have a particular device for actually mammography, separate device, and for your x-ray, like when you're doing this x-ray, common x-ray, that have a different device. Okay. Okay.
স্যার এমনিতে এক্সরে করলে তো আমাদের বডির ক্ষতি হয়, লাইক
হ্যাঁ, ওটা
কিছু
নিয়ে আমি বলবো।
পরিমাণ এনার্জি তো
হ্যাঁ, ওটা
অ্যাবসর্ব
নিয়ে আমি
হয়,
বলবো।
মানে
ওটা নিয়ে আমি একটু পরে
1% এনার্জি যে থাকে ওইটার মধ্যেও আবার এনার্জি আমাদের বডিতে মানে অ্যাবসর্ব হয়,
Absorb.
মানে ওই 1% এর উপর বেস করে তো না কি হচ্ছে 99% এর মধ্যেও আবার ওটা আসে বডিতে।
1% আসতেছে, 99% হচ্ছে heat. Heat does not actually have any harm towards the body. This heat that is generated inside, we absorb those things. ওটা আমাদের বডিতে খুব একটা আসতেছে না। যেটা মেইনলি আমাদেরকে এফেক্ট করতেছে সেটা হচ্ছে যে হাই ফ্রিকোয়েন্সি ফোটন গুলো, এক্সরে, যেটা আমাদের বডিকে পেনিট্রেট করতেছে। ঠিক আছে, দিস ইজ হার্মফুল।
আর স্যার হাই ফ্রিকোয়েন্সির যে ফোটন গুলো আসতেছে ওটা যে অ্যালুমিনিয়াম দিয়ে পাস করতেছে, তারপরেও কি কোনো এনার্জি অ্যাবসর্ব হচ্ছে না? মানে
আমাদের
ওটার কি
বডিতে
এনার্জি কমে যাচ্ছে না, মানে অ্যালুমিনিয়াম দিয়ে যখন পাস করতেছে হাই ফ্রিকোয়েন্সির ফোটনস?
আচ্ছা, হাই ফ্রিকোয়েন্সি ফোটনস যেগুলো পাস করতেছে, সেটা যে অ্যালুমিনিয়াম প্লেটটা আমরা দিব, এটাকে খুব একটা বেশি কমাতে পারবে না। ইট উইল বি ইনাফ টু অ্যাকচুয়ালি রিডিউস দ্য omit this soft, like হচ্ছে small energy photons, but high energy photons will actually penetrate those things. It might reduce those things insignificant. Okay, whatever it will reduce, it is insignificant. We'll still get this like this visual spectrum. আমরা যে visualizationটা চাচ্ছি, it will be enough to actually do it. So that's why I said different thickness. দেখছিলাম না, this different thickness. If you are like, if your generation, the frequency, it is actually very close, you take a small thickness so that তোমার হাই এনার্জি যে ফোটন গুলো যাবে সেটা যাতে করে সুন্দর করে পেনিট্রেট করতে পারে। But if you
Okay,
are
sir.
like doing more thickness, then some of them will be absorbed. So you keep the thickness small so that only a smaller energy, those things are actually absorbed, and the high energy, they can actually pass through this material. Okay.
জি স্যার।
Okay. Acha. Now this a little bit more radiation dose. Acha, radiation dose বলতে বোঝানো হয়, so this is like the unit of based on which we actually measure. Okay. So amount of radiation you need. Okay, amount of radiation you need to achieve to get better images, accurate image. So if you have done X-ray, you see, you don't perform this X-ray frequently. There is a limitation. How longer you actually perform this X-ray, how frequently you can do this, there is a limitations. I'll show you a little bit later. So radiation dose is like how much radiation dose you at least need to get an accurate image. Okay, otherwise the image will not be formed. Okay, so this is actually related to, this is actually by exposure. Okay, exposure is sometimes is something that we actually use to actually say how much we actually exposed to X-ray radiation. So this is like absorbed radiation dose. Okay, absorbed radiation dose. Okay, now this exposure X, this is proportional to Z I V square T. Okay, this is the atomic number, I is the current, V is the voltage, T is the duration. এগুলো আমরা কন্ট্রোল করতে পারি না. This is the time. These things we cannot control. This comes from the X-ray device. Okay, what is the voltage up to which they are actually accelerated? But this time is one of the factors. So the more time you are inside or under the X-ray device, the more exposed you will be. So that's why you want to limit this portion as much as possible. Okay, limit this for a certain amount of time very closely. That is just enough to form an accurate image. That's all. Okay, and this is the unit of this one measurement is joule per meter square. Now there is another matrix. Sometimes you will also find RAD, radiation absorbed dose. Absorbed dose. It is almost similar to our this one, the exposure. Okay, so let me show you an article. Show you an article. I provide this article. Okay, very simple. Here you can see the exposure. এখানে বলা আছে exposure নিয়ে different types, risks, and read this one. It is very simple, plain and simple. You will be able to understand what it means. And if I go a little bit later, and you can see there are different types of X-ray, like which portion of the body you are performing this X-ray. And we can perform this chest X-ray. And you can see this chest X-ray is actually equivalent to 2.4 days of natural background radiation. Okay, normally we have some radiation in our environment. And chest X-ray, when you perform a chest X-ray, it is like you are getting the radiation of this amount of days in one, like within this few 5 or 10 seconds that you are exposed to the X-ray. Within a short period of time, you get this much exposure. Okay, and if we go this, you can see when you're performing a CT scan, that's like 243 days. Okay, so when performing a CT scan, you are taking the X-ray from different sides, whole different like 360-degree angle. You are just rotating the X-ray device, okay, around your head to get this CT scan. So that's like 243 days of natural background radiation. So that's too much. So you can actually do CT scan very frequently. So whenever you are doing this kind of X-ray or CT scan, you have to be the doctors, they have to be very cautious that they don't give you these things frequently. Only when it is extremely necessary, then you should go for X-ray. Okay, things like that. And there are some side effects, and you can actually read about those things. Very straightforward, but they read. Okay, so this is within the syllabus. Any question?
No, sir.
Now, now the X-ray image formation. We need to understand how these X-ray images are actually formed to get some better idea. Okay, better idea. Now, you see, this comes from attenuation. This idea comes from attenuation. So, in different tissues, attenuation in different tissues, the attenuation is actually different in different tissue. So, this is we have attenuation coefficient, attenuation or absorption coefficient. So if I give you plot a graph like this way, and etc. See, when I have this 10 kilo electron volt, this is your bone, this is your muscle, this is your fat. Okay, so you see, when you have this 10 kilo electron volt, will it be able to penetrate the muscle? That's the energy of the photon. Muscle, bone, কোনো কিছু penetrate করতে পারবে?
No, sir.
পারবে না, তাই না? So when it is in like 10 kilo electron volt, 1 mega electron volt, then 10 mega. Okay, so you see this range 10 kilovolt. When you have the energy is very small, it will not be able to penetrate. Okay, if the energy is too high, then it will penetrate very quickly. See, to form the image, to form an image, you need contrast. Contrast between different segments. Between different segments. If you remember the arm X-ray image that I actually showed you in the lab, you need to have some contrast between your muscle, bone, fat, everything, so that you can actually distinguish properly. Okay, so you need to find the voltage range on which you have the better contrast. Okay, and this is a very extremely important whenever we are using this formation. It is very important to get good contrast. So you can see when you are around this 100 kilovolt, okay, around this 100 kilovolt, you can differentiate this muscle very easily from the muscles, and differentiate this bone very easily with the muscles as well as the fat. Okay, so this is very easy to differentiate. You see there is a much difference. So you can actually, when you are using a particular electron volt range, 100 electron volt, you can easily differentiate which is your bone and which is your muscle. That's why X-ray is very useful, okay, for that kind of hard X-ray. Okay, that kind of task when you're doing this chest X-ray or for some bone X-ray for some part of the body. X-ray is very useful in those range in particular. But you see, when you have this in the soft region, like this fat and muscle, the difference is very small. So it is very difficult for you to difference this small segment. That's why when you are using this very soft, like soft tissue, when you are trying to differentiate, you have some other imaging modalities, because X-ray does not provide very good variation in that range. Okay, আমি কি বোঝাতে পারছি জিনিসটা, ইমেজিং এর জিনিসটা বোঝা যাচ্ছে?
Yes, sir.
So if I put it in a mathematical context, so if we have this incident intensity of X-ray image is I naught, and the transmitted intensity is equals to I. So your I is equals to I naught e to the power minus alpha into X. This alpha is your absorption coefficient. Okay, and this X is your thickness of whatever you're trying to pass through, or whatever object you are trying to pass through. So different biological object, like your bones and fat and muscle, everything has a different absorption coefficient alpha. Okay, so when you are trying to form these images, okay, you want to find particular voltage range, particular V, where you have better contrast, so that you can actually differentiate between different segments of the body, different regions of the body. Okay, if they are not differentiable, then you will not get a good contrast. So you will not be able to differentiate what is your bone. Everything will look the same. What is your bone, what is your muscle, both will look the same if there is not a good contrast between those things. So that idea forms in the image segmentation portion. মনে আছে পড়েছিলাম?
Sir.
So that is where we need this concept of image segmentation. Okay, so in image segmentation, even if you have like the X-ray image where you are not getting a better contrast, okay, your X-ray image quality was very poor, so you have the bone structure and you have the muscle, but you are not getting good contrast, you are not able to see it properly. But using this image processing techniques like image segmentation, you can differentiate this bone with the muscle very clearly. So this comes after your X-ray. After you form the X-ray image, then you can perform some processing task using which this segmentation task, using which you can actually achieve this better segmentation between different portions of the region, different regions. বোঝা যাচ্ছে আমার কথা?
Yes.
So like this way, image segmentation, the image processing part Okay, so there is actually this course should actually come after digital image processing. You had another course, digital image processing. So this image segmentation, okay, region growing, then image registration, all of these things actually falls under that topic. But since you don't have that course, you'll try to cover a little bit with different things a little bit so that you can actually have some understanding. Acha, any more question? Any questions up to this portion?
একটা লাইন বুঝিনি স্যার, ওই অ্যাটেনুয়েশন ইন ডিফারেন্ট টিস্যু, ওটা দিয়ে কি বুঝিয়েছে?
Attenuation in different.
ডিফারেন্ট টিস্যু, ওই যে ফার্স্ট একদম স্যার আগের পেজ।
Acha, attenuation in different tissue. You see, যখন X-ray, so the X-ray image, X-ray radiation. Okay, so let's say this frequency, X-ray radiation. So it can pass through our bone. Some of the wavelength will be able to pass through our bone, but some of the X-ray will be able to pass through our muscle, but will not be able to pass through our bones. So to quantify it, you have this attenuation coefficient. How much this X-ray, this wavelength, this radiation actually attenuate when it passes through this particular object. So the same wavelength, it may actually have passed through the muscle very clearly. So you have very good, very less attenuation here. But in the bone, it has a very high attenuation. Okay, so that's why you are like able to differentiate between the bone and the muscle. এটাই বোঝানো হচ্ছিল, ঠিক আছে?
এই স্যার বুঝছি।
আচ্ছা, now also the image segmentation idea, I believe you have some idea. Now we'll talk a little bit more about these image forms, how these images are formed in X-ray images in the next class, along with the computed tomography CT. But before we finish, so one of the things that is like, acha, why do you need X-ray? Why do you doing? If acha, let me complications of X-ray. Okay, this is an important topic. How different complications. এখানে বোঝার কিছু নাই, জাস্ট আমি একটা আর্টিকেল দিব, তুমি পড়ে নিও নিজের মতো করে. So you see the complications that actually happens from X-ray is like, X-ray is a very high energy photons, right? High energy photons with very small wavelength in the nanometer range. So when you have these very high energy photons, they actually interact with our molecules of the body. They actually interact with the molecules of the body. How they interact, you see, when these high energy photons in our molecules, when they eject the electron passes, শেষ কক্ষপথের ইলেকট্রন আর সেখানে একটা ধাক্কা মারবে, ইলেকট্রনে কি হয়ে যাবে? বের হয়ে দৌড় মারবে. So when you have these high energy photons, okay, when they try to interact with the molecules, they can cause the ejection of certain electrons in the molecules. Okay, even exactly in the molecular level, very tiny level. So ejection of electrons from the orbital electrons can happen. So when you have this electron ejected, what happens to this molecule? It becomes a ion, right? It becomes an ion. And these ions are unstable. Okay, unstable, and they are very much chemically aggressive. They are very aggressive. Okay, so they actually react. So there are different reactions. Reactions bolte, like if it is like reacting this X-ray images, high energy photon, if it is reacting with the DNA molecules, so this is called, it will change your DNA. Okay, এটাকে বলা হয় mutagenic change. Okay, so it can have some so X-ray is not actually, never is actually should be allowed, because it can actually change, but the effect, the long time effect is limited. Acha, so when you have these mutagenic changes in the DNA, it can happen. Also, it can also cause life shortening. Some of the X-rays, like you saw in the CT X-ray, it can actually have a long exposure in your body. That should actually can also affect your life. Okay, it can shorten your time. Also can cause cancers. This kind of change in the DNA can also cause cancer. It can also, if you are like not properly precaution যদি না নেওয়া হয়, it can also be lethal. Okay, lethal. So study about this topic, complications of the X-ray, from some online materials. Okay, এটা নিয়ে আমরা বেশি কিছু বলতেছি না, পড়ে দেখিও নিজেরা বিভিন্ন অনলাইন থেকে আর্টিকেল থেকে. So what are the effects of X-ray in the human body? Okay, but still you see some of the X-rays, like when you are doing for arm X-ray, okay, or leg X-ray, these parts of the body are not that much that are less susceptible, so does not have much effect. But when you have like a CT scan or chest X-ray, they have more effect. Okay, but the benefit of this X-ray is it is actually very cheap. Okay, you see the X-ray does not cost you much money. It is like 1,000 টাকার মধ্যে সম্ভবত হয়ে যায়. So it is very cheap, and also it provides very good good contrast, not just good, excellent contrast, not just good plus plus, good contrast between your bones and the tissues and soft tissues. So when you are doing this chest X-ray, you can actually, when you have some problems, you can actually very easily identify this difference. Also, if you have some tumors, okay, if you have some tumors, if you can use like a CT scan, it can also actually, CT scan means it is rotating around the body, so 360-degree view. So it can also very easily identify the location of the tumor. And this CT scan is relatively cheap. So people don't want to go for MRI because it is more expensive. So CT scans will be more cheaper. That's why doctor actually prescribe this kind of CT scan or X-ray images extra fast. Also, you see this contrast is very important because the main purpose of this X-ray is to form an image that will help you understand like whatever your architecture, bone structure is, whatever the other portion is, whatever other problem is. If you don't get good contrast, you will not be able to visualize properly. And that things happens in like when you are doing ultrasound imaging. Okay, ultrasound is another imaging modality. We'll talk about ultrasound inshallah. So this ultrasound imaging, you will see the problem with ultrasound imaging is it is less contrast. এটা থেকে ভালো আইডিয়া পাওয়া খুব কঠিন। ওকে, জাস্ট লাইক ইন এক্স-রে, even a normal person can actually understand, but ultrasound imaging, it actually has less contrast, so it is very difficult to differentiate different portions, different regions from that type of imaging. So that's why you have this X-ray imaging, very simple, very cheap, and it's still used very frequently. Okay, any question?
No, sir.
Okay, so this is for today. In the next class, we'll also talk about X-ray and we'll finish this topic in the next class. So you can write your student ID comment section.
স্যার কুইজ ওয়ানের জন্য কি ওই ওই লিনেট অ্যালেক্সনেট এসবের আর্টিকেল অনেক ডিটেলস পড়তে হবে লাইক
না না না, ওগুলা থেকে জাস্ট মেইন যেটা পড়তে হবে সেটা হচ্ছে লাইক মেইন টপিক গুলা, লাইক তোমার রেজনেটের কি ইন্ট্রোডিউস করছে, বা রেজনেট হচ্ছে তোমার ভিজিজিনের থেকে কিভাবে ডিফারেন্ট, মেইন আইডিয়াটা। যেমন রেজনেটের আইডিয়া হচ্ছে রিসাইডিয়াল নেটওয়ার্ক, সো ইউ হ্যাভ টু আন্ডারস্ট্যান্ড এই জায়গায় হচ্ছে এই জিনিসটা ডিফারেন্ট। ওকে, বা ভিজিজিনেট কিভাবে হচ্ছে অন্যগুলো থেকে ডিফারেন্ট, ইনসেপশন কিভাবে ডিফারেন্ট, এই পয়েন্টটা জাস্ট। ওকে,
আর স্যার মিডের সিলেবাসটা মানে
মিডের সিলেবাস আমি এখনো শেষ এটা গেল হচ্ছে তোমার লাস্ট উইকে ক্লাস মিস গেছিল, সেটার ক্লাস এখন নিলাম। তারপর এক উইক আছে, সো এক্সট্রা শেষ করার পর আরেকটা জিনিস পড়াতে হবে, ওটা সহ মিড টার্ম থাকবে।
ওকে
হুম, হুম, হুম।